Before we start the show, I really want to tell you that the documentary our team created, The First Hymn, is going to be in American cinemas on March 24 and 26, right around the country. The film tells the story of the oldest Christian hymn ever discovered, complete with words and musical notation. It dates from the 200s AD. In The First Hymn, this ancient song is carefully reworked by the wonderful Chris Tomlin and Ben Fielding. Both the original song and Chris and Ben's recreation are powerful reminders that there is a shared core of the Christian faith going right back to the beginning. It's all about the Father, Son, and Holy Spirit, the only giver of all good gifts. After a super successful run in Australia and New Zealand, I'm thrilled it's now coming to cinemas across the US on March 24 and 26. It's really soon. I'd love our Undeceptions listeners, especially if you're in the US, to get right behind it. The more people who go to these special nights, the more likely the season is going to be extended. So please tell your friends, drag them along. Tickets are on sale now. Head to thefirsthymnmovie.com to book your tickets today. Thefirsthymnmovie.com. Okay, on to the show. An Undeceptions podcast.
To me, the argument today is about one paragraph in Dennis's excellent book, Dance to the Tune of Life, which is a wonderful book, except that it's wrong.
How the tables turn.
That's Richard Dawkins, evolutionary biologist, science communicator, and probably the world's best-known living atheist. In 2022, Dawkins sat down on stage with renowned biologist and physiologist Dennis Noble in a kind of Clash of the Titans event. It was part of the How the Light Gets In festival at Hay-on-Wye in the UK, the biggest philosophy and music festival in the world. Sounds pretty fun. Dawkins and Noble were there to re-examine Dawkins' landmark theory laid out 50 years ago this year in his book The Selfish Gene. To explain evolution, Dawkins popularised a powerful metaphor. Living things are like survival machines, he said. We live only for the purpose of passing on genes to the next generation. Genes, or replicators, make copies of each other and transmit themselves faithfully from one generation to the next. Their vehicles are the organism, a plant or an animal or humans.
This book will show that there are no genes for anything. Living organisms have functions which use genes to make the molecules they need. Genes are used. They are not active causes. Now, I think that's a wonderful sentence because although it's wrong, it's clear. It's absolutely clear and open and articulate. And that makes my job relatively easy because I want to show that the exact opposite is true. The truth is opposite. Genes use individuals, use organisms as tools for their own propagation. If Dennis is right, then I've been wrong for 50 years, and so have actually most of the people now working in the field.
Dawkins has spent his life talking about a gene-centric view of evolution. The gene is the primary unit of evolution, and genes build organisms and compete to ensure their own survival. Life itself is an automatic and pitiless machine. Since Charles Darwin's 1859 book On the Origin of Species, evolution has been considered by many as the final nail in the coffin for religion. Because the mutations behind evolution are random, so the story goes, there's no plan. Because evolution is blind, there's no design. As Dawkins wrote in another of his famous books, Darwin made it possible to be an intellectually fulfilled atheist. Well, my guests today are among the many others who raise a question about the randomness of evolution and its alleged conflict with Christianity. They suggest that the latest research into mutation and selection, the evolutionary process, can just as easily indicate intention built into the fabric of things. They point out that there's a quiet revolution going on in the top tier of evolutionary scientists, and the revolution doesn't have much time for the metaphor of a blind watchmaker. The evidence is building, and Dawkins himself detects this, that words like blind and random aren't the right ones for evolution. We'll be treading pretty carefully in this episode because it's sort of a new field of science. But here's the punchline. Scientists, including Dawkins' own revered mentor, Dennis Noble, are starting to talk about patterns in evolution, algorithms, agency, and, shock horror, even intention. I'm John Dickson, and this is Undeceptions. This season of Undeceptions is sponsored by Zondervan Academic. You can get discounts on their special Master Lectures video courses and free chapters of many of the books we talk about here on the pod by going to zondervanacademic.com/undeceptions. Every episode of Undeceptions, we explore some aspect of life, faith, history, science, culture, or ethics that's either much misunderstood or mostly forgotten. With the help of people who know what they're talking about, we're trying to undeceive ourselves and let the truth out.
All right, Lawrence Girls, that was directed to you, so we'll go to you first and then we'll hear from the rest of the panel.
Okay, well, I've recently in the United States just stated that teaching creationism is child abuse, and I think it is. Namely, if you withhold knowledge or you do anything to children that puts them at a competitive disadvantage as adults, it's child abuse. It's mild forms of child abuse, but it's like withholding medicine, withholding knowledge.
Back in 2014, I was invited to appear on the Australian Broadcasting Corporation's then premier panel program, Q&A. They also invited Canadian-American theoretical physicist and cosmologist Lawrence Krauss, who at the time was doing the rounds as a proponent of a very strident anti-religious atheism. He's the "we got the universe from nothing" guy. In that clip, Krauss has just been asked whether teaching a creationist view of the world, specifically that the Earth is only 6,000 years old, and rejecting evolution, was wrong. It was so wrong, Krauss said, it amounted to child abuse. Part of my response, which he didn't like at all, was to point out that the comparison was an insult, not so much to creationists, which of course it was, but to anyone who had experienced genuine child abuse. He didn't like much of what I said.
This is going to be an agree fest, I think.
Great.
I agree, but for one thing that I think lowers the tone. On the science, I totally agree. And you'll find that most mainstream Christians are very comfortable with science and with all of the discoveries of science, including the 13.72 billion years ago there was a bang, and evolution by natural selection. This is standard. And I've got plenty of friends who are six-day creationists, and I'm going to get some love mail after this for sure. But look, I have great relationships with them. I just think they're wrong on the science, wrong on the Bible. The only thing I want to...
Science, because, and I think it's fear. The reason this is happening is that there are a lot of people who think that science will remove their faith. And therefore, it's better that their kids not know how the universe really works for fear that they might stop believing in God. But that's the same thing that drives the Taliban.
Okay,
and they don't want
what
kids
you
to
should
be
be doing,
educated.
Lawrence, what you should be doing, here's a little tactic. Hand them over to us. People like the Centre for Public Christianity, where I work, who are trying to educate not only the general public, but also the Christian public on biblical scholarship and scientific scholarship. To call it child abuse, I just think is all wrong.
When you say hand them over to us, do you mean the people who are teaching these things should actually be handed over to you for re-education?
Yeah,
Is that what you're saying?
yeah. We have this little prison out the back. No, look.
Okay, hang on.
I just mean, we could be the friend. We could be the friend to the new atheism and have the effect you want. I think all you're doing is firming up the opposition.
Okay, well, I'm just going to hear from the rest of the panellists.
A few days later, I wrote a follow-up to express my regret that I hadn't been more gracious to my six-day creationist friends. Director Mark has never forgiven me. I publicly apologised, and I've tried to do better in the last decade. I still think young Earth creationism and denial of evolution is a mistake, but I was an idiot to suggest that those who hold those views needed re-education. I know a bunch of informed, faithful Christian young Earth creationists, and I hope they'll put up with my conviction throughout this episode that Genesis 1 was never intended to be read concretely, that the universe is likely almost 14 billion years old, and that all of life, including humans, evolved. I reckon the great Billy Graham, one of the 20th century's most influential Christians, put it pretty well.
I don't think there's any conflict at all between science today and the scriptures. I think that we have misinterpreted the scriptures many times, and we've tried to make the scriptures say things they weren't meant to say. I think that we have made a mistake by thinking the Bible is a scientific book. The Bible is not a book of science. The Bible is a book of redemption. And of course I accept the creation story. I believe that God did create the universe. I believe that God created man. And whether it came by an evolutionary process and at a certain point he took this person or being and made him a living soul or not, does not change the fact that God did create man. Whichever way God did it makes no difference as to what man is and man's relationship to God. Billy Graham, Personal Thoughts of a Public Man.
The point that will become clear in this episode is that nothing in evolutionary theory is detrimental to a robust classical Christian faith. In fact, the new insights into evolution we're exploring today ought to strengthen our impression that the universe looks intended.
As you know, evolution is a real point of contention among Christians. There are large groups...
That's Cy Gart, a biochemist who was a tenured professor at New York University, Rutgers University, and the University of Pittsburgh before his semi-retirement. Cy has published over 200 peer-reviewed scientific papers, 3 scientific monographs, and several books, including his latest, Beyond Evolution: How New Discoveries in the Science of Life Point to God. That's provocative.
Among Christians. There are large groups of Christians who believe that evolution is really, anti-biblical, anti-Christian. Some atheist biologists, for example, Richard Dawkins, who is one of the major proponents of evolutionary theory, has said that, evolution, the science of evolution makes it possible to be an intellectually fulfilled atheist. The reality is that evolution has nothing to do with atheism. That's just false. And in fact, the other reality about evolution is that it's really doesn't make any sense that Christians should be arguing about it. And the reason I say that is most of the arguments, both pro and con evolution, are not accurate. They're being made by people who don't really understand the science, especially not the modern science of evolution. The modern science of evolution, again, has nothing to do with atheism. It's not anti-biblical. There are people who are Christian evolutionary creationists who get very angry at the young Earth creationists and say they're denying science. And my view is, let's agree to disagree. This is not a life and death issue. This is not something of huge importance compared to what else is going on in the world.
Part of the problem is that the term evolution means something different depending on who you're speaking to, even among the scientists working in the field. So right up front, let's try and define our terms. And to do that, I asked my friend Ard Louis, who's beloved here at Undeceptions. Ard is Professor of Theoretical Physics at the University of Oxford, where he's working on a broad interdisciplinary set of problems: self-assembling DNA, theories of evolution, the dynamics of soft matter, machine learning, and applications of algorithmic information theory. I talked to him recently in his office next to the beautiful university parks in Oxford. Sitting in the corner of the office were my daughter, Josie. Hi, darling. And one of my students from Wheaton. G'day, James. Trying to stay very still and silent.
Evolution has two steps. The first is you've got some kind of random mutations that generate new phenotypes, is a fancy word for, some difference from the offspring to the parents. And then there's natural selection, which selects on phenotypes that generate more offspring. So very roughly speaking, right, natural selection means, if the Louis genes mean that each of us, my children have two children, they have two children, whereas the Dickson genes, you have 4 and 4, then, after one generation, you're twice as big. After 2 generations, you're 4 times as big. And after not too many generations, there's only Dicksons and no more Louis left. So that's natural selection, basically. So most of evolutionary theorizing is about that second step. And you can think of lots of complicated ways that might work. But I'm interested in that first step.
Evolution is just change over time. And scientists have identified 2 basic components of the process. Part 1 is mutation, which gives us the variation, the differences we see in individuals. Part 2 is natural selection. That's where the mutations more conducive to survival get to, survive and be passed on to the offspring.
And so what I think is that although many mutations are random, their outcomes are not random at all. If any mutations can happen, and the things of what they can make, only a small number of things can happen and many things can't. And so the big question is, how much of what we see in nature can we explain without needing to invoke selection at all, but just by saying some things are easier to evolve than others? That's the big picture question. Yeah. And then I'm using ideas from physics to try to make these predictions. So these predictions are hard to do, but then we are finding systems where we think we can do it, and then we can use math and computers to make predictions, and then we look at biological organisms and see, can we explain something about them? So one example would be, we predict that leaf shapes are easier to make if they're simple than if they're complicated leaf shapes. And so what we've done is looked at a lot of data of leaves, and we've looked at a lot of data, evolutionary data on leaves. So like what they call phylogenetic trees, which is a fancy word for you try to figure out how all the leaves are linked to each other. And it's known from there that complex leaves, so leaves with complicated shapes, are much more likely to mutate to simple leaves than the other way around. And so then we have a model that says, can we explain that? And explain how often it happens, how frequently it happens, by ignoring natural selection entirely. So we think we can, and that's exciting for us, obviously.
Physics is normally seen as the discipline that sees orderly patterns.
That's right.
In fundamental realities, more than biology. Is that a fair statement?
So I would say it's at least slightly different, because biologists see a lot of order all through the biological world as well. But physicists are much more likely to believe that there are relatively simple rules or laws that govern a lot of things that are very general. But biologists tend to think that every single organism is different in some very special way. That's actually true, that they're different in a special way. But physicists are much more likely to think that there's going to be some general uniform rule. Yeah. So why this is actually quite important in my own move into working on evolution, because I used to talk to my biology friends and they would say, evolution is just random. In other words, what you see today is a product of historical contingency. If you were to rewind the tape of life back to where it was, a few 100 million years ago, and rewind it again, you get nothing like what we see today. And then I thought, well, that's fine. but it's hard for a physicist to study because there's no pattern there, there's no rules, it's just what happened in contingent history. And then when I started talking to a friend of mine, Simon Conway Morris, who's a paleontologist, who's been emphasizing that actually certain things evolve again and again and again, and it's extraordinary. And for you Australians, right, you've got you've our marsupial wolf, a whole bunch of animals that are very similar to animals that are placental, which basically means animals that have their young inside, versus marsupials who have their young in a pouch. But these evolved completely independently. So the wolf-like animal has evolved with no common ancestor except a very, very distant one to the other wolves that we see. And that was it. When I realized that was true all through biology.
So unconnected to each other, they found the very similar solutions.
Solutions, exactly.
We have talked to Ard briefly about this before, way back in episode 6. Whoa, that seems a long time ago. And in my work at Australia's Centre for Public Christianity, we spoke to Professor Simon Conway Morris. He's the Professor of Evolutionary Paleobiology at the University of Cambridge. He's one of the leaders in what scientists call convergence theory. Contrary to the typical claim about evolution as random and directionless, it turns out that unrelated species independently evolve similar traits when faced with similar environmental pressures. We might think of mutations in theory as a massive smorgasbord of options, and there's no rhyme or reason why one dish might be served up over another. In truth, it's more like a very narrow menu. The number of dishes of viable solutions to environmental pressures is surprisingly small.
So my favorite example is the camera eye. Okay, so we've got a lens and a retina. Octopuses also have a lens and a retina. And you may ask yourself, okay, so maybe our common ancestor had an eye, but that's definitely not true. So we've independently evolved the eyes. And, a camera eye is a very odd thing. It kind of doesn't really work unless you have a lens and a retina and everything together. How does that evolve? And yet it's evolved at least twice. We think many more times. So there's worms that have camera eyes, and all these animals evolve camera eyes independently of each other. And if you look very carefully, so for example, the octopus camera eye has this optic nerve on the back of the retina, so they don't have a blind spot like we do, because ours connects to the front of the retina, so we have a blind spot. So those are there's differences, but basically they're two camera eyes. Now that's extraordinary. So when I first learned about that, I thought, okay, now there's a pattern, okay? Something's repeated multiple times. How did that happen is really hard to understand. It seems extraordinary, but it tells me there's something much more ordered in the evolutionary process.
Something much more ordered in the evolutionary process. I love it. It's a remarkable statement coming from someone at the forefront of the mathematics of mutation. The standard neo-Darwinian model combines Darwin's theory of natural selection with Gregor Mendel's work on genetic inheritance. Completely random mutations happen. Nature allows just a few to survive, and those changes are then passed on to the next generation. Simple. But it's not so simple.
But randomness seems to be like a key doctrine in the neo-Darwinian model. Yeah. And as a result, people think that that's an indicator against God, that it's contrary to God, that random... And this is a view that atheists would propose. Yeah. Look, it's all just random. But it's also a reason why some Christians are against evolution, because of randomness. Yeah. Before we talk about whether randomness is a good idea or not, do you think if evolution was completely random, it would be a tell against the existence of a mind behind things?
So I think you could run that argument both ways. So I've got Christian theology friends who say they would prefer it to be, I wouldn't use the word random, but contingent. In other words, if you rerun it again, a different outcome would happen, because then it means that God doesn't have to do much. A little tweak here that's imperceptible and something like humans appears. And the feeling is that you don't want God to be intervening too much in nature, because God creates nature. You want nature to be running on its own. So this gives God easy access to agency. My physicist brain says, oh no, it should be ordered, because we see all this beautiful order in the physical world, which we understand, there must be some deep order underlying the biology. So I'm, by that side, much less likely to believe in the contingent story. And surely the convergence gives very strong counter evidence to it. Where this thing gets very tricky is that the word random means something very specific in the scientific context, but it has all kinds of overtones for the general public. Random means purposeless. And so if you look at some of the great fathers of the modern synthesicists, they conflate these words as well. So James Gaylord Simpson, a famous paleontologist, said, man is the product of a process which did not have him in mind. Right? He was not planned. They basically mean it's random, therefore there's no plan, there's no order to it. Christians with a high doctrine of God's sovereignty would take issue with that. And they would take issue with that on the basis of our own lives, have all kinds of things that happen to us that seem random, right? And you could interpret them as random. I happened to get into Oxford University, right, because somebody looked favorably on my application. If not, I would have gone somewhere else. Many things like that happen in our lives that seem to be not in our control. And yet we believe that God is in control and God is guiding us in one way or the other. And so that same theological view could be held towards a more contingent evolutionary and be just fine.
Yeah.
So when I sometimes explain to people that think about your life and if you're a Christian, how you think God is involved in that world that you have, even though it seems random at surface, you can make the same analogy to biological evolution. Similarly, just because biological evolution has these random elements doesn't mean that it's therefore God is not involved. But I think I think I said this to you before, which is I would prefer it if we would use a different word for the kind of randomness we mean in biology, and that's the word stochastic. It's a fancy word. It basically means processes for which you don't have any memory in them, or processes that are effectively random. But the reason I like that word is because the general public doesn't have another meaning for it except for what it means, technically. And so that kind of idea that random means purposeless, means no meaning, that is not there.
Yeah.
And then there's a really interesting way of thinking about this, which is we use these stochastic processes all the time in engineering, in physics, in finance, because when you've got a complicated problem you're trying to optimize, it turns out that these random processes are by far the most effective way of optimizing them. So that we call something called Monte Carlo methods. So if you go to a bank and you get a mortgage, that interest rate is partially determined by somebody who's modeling the stock market with a stochastic process. Okay, we don't think the stock market is genuinely random. We just think it's a good approximation to what's happening. And if you go and drive across a bridge, an engineer will have used a Monte Carlo stochastic process to calculate all kinds of properties of that bridge because they're the most efficient way of calculating things. So you see this in our own bodies. So we have an immune system that uses exactly this random mutation model and selection to allow a small number of proteins that generate the antibodies for us to generate a really wide range of antibodies. And when a pathogen comes into your body, like I've got a cold right now, so my immune system then starts quickly creating these new molecules that will bind to whatever this cold virus is creating. And that is a very efficient way of a small number of elements making a really wide range of different possible antibodies. And it's very efficient, very quick. And probably if I were God and we're going to devise an immune system, I would use this random process. But I could say this, basically your immune system uses a random process very similar to the evolutionary process to generate a wide range of diversity that's needed for your body. And it's the most efficient way of doing it.
Yeah.
Which
sounds very strange that something that's random, in inverted commas, is also highly efficient.
Exactly, and that's why I think if I use the word stochastic, then suddenly, then you're not surprised. You think, well, it's some sciencey thing, right? Yeah. But if I use the word random, then you go, oh, that can't be true because random means purposeless. How could your immune system use a purposeless system?
I love it.
And that's because you're just not thinking about it right.
Yeah.
So I think that the fact that God created, if God wants to create things over a long period of time, which God seems to want to do in redemption history as well, then using this stochastic process, that something like evolution is probably the most efficient and best way of generating all the endless forms most beautiful that we see.
Endless forms most beautiful. That's a quote from Darwin himself, by the way. It's part of the last lines of On the Origin of Species. After the break, we're going to delve deeper into how these endless forms most beautiful came to be. This episode of Undeceptions is brought to you by Zondervan Academic and a new book by Nadia Williams called Christians Reading Classics. Why should anyone, believer or skeptic, bother reading the great works of the ancient Greek and Roman world? What could writers like Homer, Livy, or Plato possibly have to say to modern readers, especially those wrestling with life's bigger questions? Well, that's the question at the heart of Nadia's book, and her answer is quite a lot. Nadia introduces readers to these ancient voices and offers 3 compelling reasons to explore them: to better understand the world Christianity emerged from, to grow in wisdom and character, and intriguingly, to be surprised by joy. You'll have to read the book to find out what she means by that last one. Along the way, she shows how the Christian story both overlaps with and challenges the ideas of the ancient world, and how Jesus speaks into some of the deepest questions those writers were already asking. Truly, it is a fabulous book. If you'd like to learn more, head to zondervanacademic.com/undeceptions. zondervanacademic.com/undeceptions. In Burundi, East Africa, 1.9 million Burundians face crisis levels of food insecurity. My friends at Anglican Aid are partnering with the Diocese of Gitega in the country's capital to try to help out. Their project aims to boost food production by providing seeds, tools, and agricultural training for farmers. In just 4 years, food production has improved dramatically with increased crop yields of over 400%. This really works. But Anglican Aid needs your help to keep this going. If you'd like to make a donation, please head to anglicanaid.org.au/undeceptions. I'll give you that link again, anglicanaid.org.au/undeceptions. Every donation counts. Thanks so much. 50 years before Darwin published On the Origin of Species, the French biologist Jean-Baptiste Lamarck offered his own theory of evolution. Within it, he proposed that an organism could somehow acquire characteristics and then pass those characteristics onto their offspring. To illustrate his point, Lamarck wrote,
"In regard to habits, it is interesting to observe a product of them in the particular form and height of the giraffe. This animal, the largest of the mammals, is known to live in the interior of Africa, in places where the earth is nearly always arid and without herbage, obliging it to browse on the leaves of trees and to continually strive to reach up to them. It has resulted from this habit, maintained for a long time by all the individuals of the race, that the forelegs have become longer than the hind legs, and its neck has so lengthened itself that the giraffe, without standing on its hind legs, raises its head and reaches a height of 6 meters, nearly 20 feet. Lamarck, Philosophie Zoologique, 1809.
Lamarck suggested that in order for giraffes to reach the best leaves, they had to constantly strengthen and gradually lengthen their necks. And as a result, their offspring would also have slightly longer necks. In another case, a blacksmith who used and developed his arm muscles in his work would have sons with similar muscular development. It was a kind of use it or lose it idea. If the giraffes stopped having to reach for those leaves, over time and many generations, their necks would get shorter. Lamarck got plenty of things right, including the idea that we pass on characteristics through inheritance. But he was wrong about what type of characteristics were inheritable. Things you acquired during your life, muscles you worked hard at the gym, or being a good piano player, are not passed on to our offspring. It might sound laughable today, and Lamarck has been the butt of scientific jokes for at least 100 years or more. The entrenched view now is that it's not possible for an organism to have any effect on its genes. The genes are the things in the driver's seat. The organism is just along for the ride. But this is exactly what some leading experts are questioning.
So that was pretty much a hardcore dogma. And so people like Dennis Noble are saying, actually, it's not really true. We see that there are things that can happen in your lifetime that can affect your offspring. This is through something called epigenetic changes, where it changes to your genes. And there's many examples of this that are now pretty well established. What's not well established is, how pervasive this is. And so there are a bunch of...
Epigenetics is a relatively new field of study. Epi is just Greek for upon or around. So epigenetics is about what happens around or on top of our genes. For a long time, we thought DNA was basically the whole story. It's a fixed code inherited from your parents. And in one sense, that's true. The sequence itself doesn't change. The letters, they remain the same. But scientists have discovered that chemical tags can attach to DNA and to the structures that hold the DNA in place. These tags don't rewrite the code, they regulate it. They can turn genes up, turn them down, or switch them off. We know that environment shapes the body. Toxins raise cancer risk. Exercise strengthens the heart. What epigenetics shows is that environment and behaviour can also leave molecular marks that affect how genes are expressed. Think of DNA as the book of you. Epigenetics is like the highlighting or the sticky notes, the bits underlined in red. The text doesn't change, but how you read the text is changed. This doesn't overthrow evolutionary theory, nor does it vindicate old Lamarck, but it does add nuance. Evolution isn't just about changes in DNA sequences across generations. It's also about how genes are regulated and expressed, and that makes the picture richer and more interesting. James Shapiro, who's one of these, I guess,
one of the
geneticists.
Geneticist, exactly.
He, and I'm going to quote him, the capacity of living organisms to alter their own heredity is undeniable.
Yeah, that's right.
Is it?
I think it is, yeah. So this, to some extent it is. I think so James might be on the more enthusiastic side of that spectrum.
This is one of the things Richard Dawkins and his mentor Dennis Noble disagreed about at the top of the show. Dawkins clings to the idea that random mutations are the only way to introduce variation. Newer research suggests that might not be right. Back to Cy Gart.
Well, here's the thing. Let's say you're a happy bacteria. You're an E. coli, and you're living in the gut of me, say. Okay, you're in my gut, along with all your friends. And you're happily chomping on all the sugar you can get because sugar is the best thing for you. You love to metabolize it. All of a sudden, I go on a real diet. I decide no more sugar. That's not good for me. And I start eating other stuff. Well, that's not good. That's not good for... Well, who are you? Okay, you're the E. coli. That's not good for you, right? Because you have no sugar to eat. You and your friends start getting sick, and some of them die. So what do you do as a group? Here's what you do. Not you alone, but the whole group of bacteria who are living in that gut change the way they replicate, and on purpose, especially in the area that has to do with, in the genes that have to do with metabolizing various foods, they begin to mutate at a high rate. And since most mutations are bad, most of your friends die. But you and a few others got lucky. You ended up with a mutation that allows you to metabolize something completely different. Let's say, I don't know, alcohol, and I'm still drinking. Okay, so that's good. So now you survive, and so do your 3 or 4 other friends who got the same or similar mutation, and you begin to reproduce, and the whole colony grows back. This happens. This is a real event. I'm not making it up. Hypermutation is something that occurs, and the way it happens, remember, all the members of the colony have to do it at the same time for it to work. And most of them will die, but the few that survive, because they got a good mutation, that saves the whole colony. So that implies several things. First, mutations can be really beneficial in times of stress because they give you the chance to be a whole new person or a whole new bacteria. And second, it shows the cooperation between different members of that colony. There has to go a signal out to everybody saying, hey, times are bad, let's mutate. Do it now, all together. And the other thing that this shows is that there is something called targeted mutation or stress-directed mutations, SDM, which are what you said. They're mutations that occur at a specific time, at a specific location of the genome where it counts. So it's no longer true, and there's so much evidence for this. Susan Rosenberg is one of the leaders in that field. It started with some work by John Cairns back in the 80s. And it was very controversial, but it's now established that at various times you get directed mutations to a specific area of the genome where there are genes that can actually help the organism. So the random story, it's often the case, it's not the whole case. And that's why the book is beyond evolution, because we're now way ahead of that whole neo-Darwinian paradigm.
And so there are a bunch of biologists who think that we've gone down too narrow of a tunnel by not looking at these outside-of-the-box ideas, and that these outside-the-box ideas have been suppressed by a minority of biologists who want to be ideologically pure. So every thought biologist would say, we think very differently now than we thought 50 years ago about evolution. Epigenetic change might play a big role. All kinds of new things have happened that are very interesting. What they kind of disagree about is whether the new Darwinian synthesis should just be expanded, right, or whether it should be extended. And some of that is turf wars about language. Some of that is turf wars about funding and prestige and jobs. Mm-hmm. And some of it is just genuine intellectual differences about whether these new ideas are important or not.
Okay.
But we will know, in 10 years, come back in 10 years and we'll be able to give a much cleaner answer to that.
Okay.
So I think what you're watching right now is a kind of turbulent period where a lot of different voices are yelling quite loudly. And the question will be, will there be some kind of paradigm shift on this or not? And I think the jury is out.
About 10 years ago, Professor Ard Louis spoke to Dennis Noble for a documentary, Why Are We Here? Noble explained to him part of his frustration with those who hold to the narrow, or what you might call reductionist, neo-Darwinian model of evolution. Here's part of that conversation.
Here's an interesting question. So, do you think that some of the resistance you've faced from the reductionists has been a kind of fear of religion, that you're worried you're going to snake God back in?
Not only that, I found in a Novartis Foundation symposium organised by one of the great reductionists at University College London about 1997, that's Lewis Wolpert. I was one of the few to argue against the reductionist case, and I expected 2 or 3 others to help me. One did, another didn't. And he came up to me in the coffee break and said, Dennis, I would support you if I didn't think that brings God back in.
That's so weird.
And I looked at him and I could not begin to understand what he was saying. Though I do now understand the fear. Of course, in the neo-Darwinist context, it's the fear of all of those creationists. Yeah. I know that somehow or another, if you let this structure collapse, and I think it is collapsing, incidentally, it's a house of cards built on some very bad concepts and some very poor science. Poor because of the insistence that it's the only truth. If you let that crumble, what then happens? The creationists will have a field day saying, you know, you were all wrong.
Yeah. And so you think that's a major part of their resistance to accepting a challenge to reductionism, but then talking about emergence?
Yes, I believe that's part of the problem. It is as though you have to be reductionist in order to counter those ideas. I think that's the case.
Well, where do I fit them?
And someone like Richard Dawkins is unsettled by, dislikes this approach. What's his disagreement, or what's his problem with it?
I think he thinks that Dennis overstates the problem. So he thinks Dennis is overstating how important these new mechanisms are. Dennis thinks that Richard is stuck in the mid 20th century and hasn't moved on. and you know, they're both interesting thinkers. Yeah, but Richard Dawkins has not done research really for a long time. He's a popularizer, and so he is maybe a little bit behind on some of these more recent developments.
They call themselves a third way.
Yeah.
Right? So this group of scientists, I guess the first way is, you know, intelligent design. Like there's a purpose outside drawing everything.
Yeah.
But they're not that way.
No.
The other is everything's just completely random.
Yeah.
They reject that as well.
Yeah.
Their third way, I mean, you correct me if I'm wrong, is that there's something within the genes, within physical structures that pushes genetic change within a narrow band.
That's part of what they say. They think that third way is quite a broad coalition of different ideas that may not always be consistent with each other. Mm-hmm. I think what I would say is it's interesting and very kind of stimulating. Probably we would. Now I'm sounding like a biologist rather than a physicist. I want to wait until we see some more experimental evidence for some of these ideas before I would, say that revolution is upon us.
How does your work relate to them, or how would these third wayers view your work?
Well, I think it depends on the third wayer. Right? So the work I'm doing, it falls on a slightly different fault line, and that's the fault line between structuralism, which is the idea that what you see in the natural world is there because there are certain structures the natural world easily makes versus others, and that's a long history in biology of people that have looked at this. So a famous example that's very old and more that everybody agrees on is if you look at the shell of a snail, then the ones that have like round circles, then you'll find that the ratios of the radii follow Fibonacci's sequence, which is 1, 1, 2. My kids love this, and that's not because of natural selection. It's because if you make these shells, then this is a natural thing that emerges. So it's the structural constraints. You can only make shells in a certain number of ways, and so you get these patterns that come out. And so the question is, how much of what we see in nature can you describe by these mathematical patterns? Like, you have to do it this way. There's no other way of doing it. And structuralism is that way. Adaptationism is the other side, and neo-Darwinians are typically adaptationists, and they would say, no, the reason why you see that particular form is because that was what natural selection optimized, or that's what natural selection drove you towards that particular case. It's more complicated than that because natural selection is always acting with a lot of random other things happening at the same time, but this would be the origin of it. So one of the arguments in the example I gave you of these leaf shapes is the reason why we've got this bias towards simple leaf shapes. Natural selection wants these. They give a reproductive fitness advantage. That would be an adaptationist view. The structuralist view would be my view, that is the one that I'm not promoting, which is that no, it just is easier to make that simple shape than the complex shape, and so you just make what's easier, and it's due to the physics of the making of leaves that you see that.
Can you put your finger on that for me?
Yeah.
Because you're saying that there's maybe this isn't the language you'd use, a bias in physical reality
exactly.
towards simplicity and symmetry.
That's right, yeah, exactly. So one of the things I've been looking a lot at is, so I'm pretty sure that we've shown that there is a bias which works as follows. Random mutations that are basically completely uniformly random, so anything can happen with equal likelihood, have outcomes that are really highly biased towards shapes that are simple. And one of the examples of simple shapes are symmetric shapes. If something's symmetric, you only have to describe half of it, for example, and then the other half you can just say, repeat that again. And so you see a lot of symmetry in nature, or even things that are close to symmetry, and we're basically saying that's because it's much easier to make symmetric things than non-symmetric things.
Is a snowflake an
Snowflakes is an
example?
example. So snowflakes are not technically always symmetric, but they have a very simple algorithm to make them, and they make a lot of variation with them. But the reason why they have that beautiful shape is not because there's some kind of physical blueprint that remembers it, but it's because a little pattern forming, a really simple little pattern forming mechanism that generates those shapes. And so what I'm saying is these pattern forming mechanisms, like the ones that make snowflakes, are also happening in our body all the time. And so the reason why we have certain characteristics is because those are the ones that are, like snowflakes, easy to make. And so that's that fault line is how much of what you see can you explain by this is just how nature works. It's part of the physical law, like snowflakes. And how much of it is no, it's because natural selection drove you towards this particular outcome.
Yeah, but you're suggesting that actually the outcomes are in a sense predetermined by this very simple algorithm.
Exactly, yeah. So I'm saying that
in nature.
In nature, exactly. So I'm saying there's these algorithmic principles in nature that generate this.
Every few years, another article is published with a title like, "Does Evolutionary Theory Need a Rethink?" from the preeminent science journal Nature in 2014. Or, "Do we need a new theory of evolution?" That's from The Guardian in 2022. Or, "Evolution may be purposeful and it's freaking scientists out." That's from Forbes in 2024. But both Ardlui and Seigert are at pains to say that the overarching idea of evolution is not in crisis. The scientists questioning the modern synthesis, including third wayers like Dennis Noble, aren't saying evolution isn't real. They're arguing that there's more to know about how evolution works. In the Book of Psalms in the Old Testament, there's a little Hebrew word, selah. Most people take it as a cue to pause and take it all in. And that's the idea behind Selah tours. They're for people who want to slow down and explore the extraordinary history of Christianity, not just in books, but on the ground. These trips are more than a holiday, and they're much more than a pilgrimage. They are thoughtful, guided journeys through some of the most significant places in Christian history. Experiences that engage the body, especially my tour, you're exhausted at the end of the day, the mind, and for many, the soul. And the memories really do last a lifetime. You can walk in the footsteps of remarkable figures like the Venerable Bede across Scotland and northern England. You can trace the route of the Apostle Paul through Turkey, Greece, Malta, and Rome. And if you haven't had enough of me, I'll be leading a 2-week tour of Israel in late November, early December this year, visiting the key sites connected with ancient Judaism and the life of Jesus as we explore the origins of Christianity together. And by the way, we'll be doing a little half-day side trip to the West Bank to hear about the Palestinian experience in a safe and honest way. Numbers are limited, so we can keep the experience personal. Plenty of time for conversation, questions, and getting to know each other. You can book your trip now at selah.au. That's SELAH.au. Maybe I'll see you there. I want to run something by you. When I read your work and listen to you, it chimes with Aristotle's view, which was different from his teachers, Plato. Plato thought that there were ideals in the heavens, and they imposed themselves on creation. Aristotle said, no, the logos is in the things. And so they're not being drawn out from the external. There's, let's say, an algorithm, a logos in nature. And the Hebrew Bible says something similar, actually.
Yeah.
That God put his wisdom in things.
Yeah.
And that things have their own powers that are a reflection of his wisdom. But I guess my question to you is, does that feel a better way to you, to feel a better way to think about natural order than either the completely random idea or even the sometimes Christian idea that God is like poking and intervening and shaping?
So I think, I think, yes, of course, I like it better because I think it's a third way between the two extremes, right? I don't think many biologists really think that everything is random. Even, so Richard Dawkins would famously said, the mutations might be random, but the natural selection is the one that pushes you one way or the other. What that would imply is that it's the environment that does the work, right? The environment imposes itself on the organism. Right? And so if you see the marsupial wolf evolve in Australia and a placental wolf in North America, the argument would be there's a niche in that environment that wolf kinds just want to be in, and natural selection is driving it that way. And there may be some truth to that story. I think the idea that God would create a world that makes itself is just much more aesthetically beautiful than a world where God has to continuously intervene in nature. So I'll give you one analogy and one short historical story that I think helps illustrate this. So the analogy would be if I take Lego blocks and I make a train, for example, my children will be impressed I made a train. But if I could invent Lego blocks that I put them into a box with a little bit of glue and I shake the box for a little while and then I open it and it spontaneously forms a train, that would be very spectacular. I'd become very rich selling that as a toy, right? But that's what nature does all the time. And so I might see that train and see a few scratches on it because I was shaking it, right? But it would be infinitely more impressive and infinitely cooler. So I think God has done it that way. That's how God has made things that make themselves. And that seems to me much more interesting, more exciting, and more beautiful than just plunking these things down fully made.
But it's also what Aristotle said.
Yeah.
And what the Hebrew Scriptures said before Aristotle said.
Exactly. So I think it fits very much with biblical story, and I think it's much more beautiful. Now, the intervention story has another angle to it, which you probably have covered at some point in your podcast. But there's a famous exchange with Newton and effectively Leibniz or Clarke, but he was speaking for Leibniz. And Newton, when he came up with gravity, worked out how the planets move in these elliptical orbits around the sun. But there's a problem there because his gravitational law explains why the Earth has an elliptical orbit and why Jupiter has an elliptical orbit. But of course, Jupiter also pulls on the Earth because gravity pulls on everybody. And if you did the calculations, Jupiter pulling on the Earth would make the Earth unstable after a certain amount of time. And so the Earth would be ejected from the solar system. That would be bad. Therefore, Newton says, at some point, God sends a comet through, okay? And he uses that comet to kind of realign the planets when they're about to go wrong. So God intervenes every so often. He pokes it. And so Leibniz pushed back on that on two grounds. One is that basically God intervenes in redemptive history for redemptive reasons. Right? And when we say that God intervenes in the history of Israel or the history of God's people, we need God's revelation often to show that to us, or we might see something very obvious, but God's doing that for a purpose. Right? So like the word miracle in the New Testament is never just something amazing, a sign in the sky. It's always used with the words work of power or sending on a sign. Mm-hmm. It has a purpose to it. It's never just God doing something magical in the sky. So on that basis, he said, God does not do this for wants of nature, but wants of grace. That was Leibniz's words. So why would God doesn't do these miracles to solve things in nature.
Leibniz, by the way, is Gottfried Wilhelm Leibniz, a German polymath, mathematician, and scientist who, along with Isaac Newton, created calculus.
Sir Isaac Newton and his followers have a very odd opinion concerning the work of God. According to their doctrine, God Almighty wants to wind up his watch from time to time, otherwise it would cease to move. He had not, it seems, sufficient foresight to make it a perpetual motion. Nay, the machine of God's making is so imperfect, according to these gentlemen, that he is obliged to clean it now and then by an extraordinary concourse, and even to mend it as a clockmaker mends his work, who must consequently be so much the more unskilful a workman, as he is often obliged to mend his work and to set it right. According to my opinion, the same force and vigour remains always in the world, and only passes from one part of matter to another, agreeably to the laws of nature and the beautiful pre-established order. And I hold that when God works miracles, he does not do it in order to supply the wants of nature, but those of grace. Whoever thinks otherwise must needs have a very mean notion of the wisdom and power of God.
But the second thing, he says, it's much more beautiful if God were to make planets that are stable than if God has to intervene in it. And I think we intuitively think that would be somehow demeaning to God, that he couldn't make a planetary system that has a stable orbit for the Earth, and he's got to keep fixing something that he hasn't done. So God doesn't fix mistakes in his creation by poking in every so often. And so why would God create the world and then having to poke in all the time? It doesn't make any sense.
We've talked on the show before about the God of the gaps criticism, often thrown at believers. According to the criticism, theists need mysteries in science, gaps in our knowledge of how things work, so they can insert the explanation, God did it. And as science eventually discovers how those things work, the gaps get smaller. There's less and less space and less need for any reference to God. God becomes merely a God of the gaps. Now, that criticism certainly sticks to some kinds of Christian arguments, but it doesn't come close to touching the classical Christian approach to natural knowledge. The classical view, going back to Thomas Aquinas in the 13th century and all the way back to Augustine in the 4th, is almost the opposite of God of the gaps. According to these thinkers, it's the bits we do understand, not the gaps in understanding, that point to God. Because every time we discover how something in the universe works, we find that it can be described in deeply mathematical and rational ways. Scientific discoveries don't empty the universe of order and rationality. They reveal just how saturated with order and rationality it really is. And this is exactly what you'd expect on the assumption of theism, not atheism. The only way scientific discoveries would seriously call into question the idea of a mind behind the cosmos is if science began to prove that everything is utterly random, that there are no equations that accurately describe the movement of the heavens or the behavior of the atom. That, I suppose, would challenge the notion of divine intelligence. It would also discredit the very practice of science, by the way, because science depends on the orderliness of nature. But that's for another day. My point is simple. Every step forward in science gives us more, not less, natural order and intelligibility. Rationality seems to be woven into the very fabric of matter. So it's not the gaps in knowledge that suggest this, it's the knowledge itself. And here's a cool thing. Long before Augustine, before Christianity, pagan philosophers spoke of this orderliness in nature as the logos, the rational principle, the operating system behind the machine. For Plato, for example, the logos was sort of located in the heavens, in the realm of ideas, or what he called the forms. For Aristotle, his student, things were a little bit different. He said that the logos was not merely out there in some distant realm, but in natural things themselves. An acorn becomes an oak tree, not because of an ethereal idea floating in the heavens, but because the principle of oakness, we might even say the algorithm of the oak, is built into the acorn itself. In a sense, the acorn is programmed to become an oak. What fascinates me is that something similar to this was already being said by the ancient Hebrews, long before Aristotle. In the book of Proverbs, chapter 3, chapter 8, check it out yourself, Israel's sages spoke of God's wisdom embedded in creation itself. In much the same way that we might say the genius of those clever Swedes is built into every IKEA product. And Genesis 1 has its own way of saying pretty much the same thing. In an often overlooked paragraph, the Hebrew writer doesn't describe God individually crafting every plant by direct intervention. Instead, God commands the earth to bring forth vegetation, and the earth does so. The vegetation itself then produces according to its kind. It's as if the Logos is placed within the things themselves. Here's the passage. Then God said, "Let the land produce vegetation, seed-bearing plants and trees on the land that bear fruit with seed in it, according to their various kinds." And it was so. The land produced vegetation, plants bearing seed according to their kinds, and trees bearing fruit with seed in it, according to their kinds. And God saw that it was good. The genius of God is built into the fabric of the material cosmos, so that, in a certain sense, it makes itself. So when scientists discover explanations for how things work, they're not explaining away God. They're uncovering the deep rational structure that's in reality. They are, in a very real sense, peering into the mind of the Maker. That's the classical Christian view of natural knowledge.
Final question, Ard. I know you always avoid any sense that science demonstrates Christian theism.
Yeah.
That's obvious. But I guess I want to ask it the other way around. In your day-to-day work as a physicist here, do you see God, intellectually speaking, in your work?
So I definitely do. Yes, I think, when I told you when I made that discovery about the emergence of symmetry, I cried. I thought it was so beautiful. I couldn't believe that. I couldn't believe that I was the one who was privileged to see this. I walked around looking and thinking, man, I'm the one,
And you're tearing up now.
I'm tearing up now, exactly. And I remember thinking, I thank God. Thank you, God, for the privilege in my life that I was able to see this. Right? Yeah. This thing that you've made, that you've known since the beginning of time, and I was able to see it, and it's beautiful, and I thank you that I saw it. Right? And that's a natural kind of response of worship that a scientist would have. Right? Now, on that particular project, I had students who were atheists and students who was a student who was a Muslim. They might have had different experiences looking at that. And so I'm not going to say their experiences were wrong, but I do think that this is something for a Christian that's very natural. And I think that experience of seeing some beauty in the natural world, in its intricacy, in its order, is not something that only scientists see. I think the general public see that. Many people who don't believe in God nevertheless will look at the natural world and say that it points towards something bigger than ourselves. It's a very, very common intuition across cultures and across time, and I think a valid one. And so I think all that our microscopes and our telescopes do is enhance that sense of wonder and enhance that sense of amazement. So I think, by and large, science points to God. It's not a proof for God, but it points to God. And one of the ways you can think about that as well is you can do the counterfactual. Maybe the universe would have no beautiful rules, just it'd all be chaos and disorder. On atheism, that's could be just equally likely or possible. And so on theism, you might expect there to be some kind of order. Historically, that played a big role in the kind of birth of modern science, was that expectation that we should find order. And so I think on the fact that we see so much order, so much beauty, is a pointer towards God.
Ard Louis, thank you so much.
If you like what we're doing, there are a bunch of things you can do for us, and we'd love all of them. You can go to undeceptions.com and pick up one of our Undeceptions t-shirts from the store. You can become an Undeceptions Plus subscriber and get access to a bunch of extras and our special Facebook group. And if you really want to help our team, you might have the capacity to go beyond the subscription fee. You might consider making a donation. There's a big yellow button on the website. All of that helps us keep doing what we're doing. Head to undeceptions.com to check them all out. While you're there, send us a question by audio or text and I'll try and answer it in an upcoming Q&A episode. See ya. Undeceptions is hosted by me, John Dickson, produced by Kaley Payne, and directed by Mark Hadley. Alasdair Belling is a writer-researcher. Siobhan McGuiness is our online librarian. Lyndie Leviston remains my wonderful assistant. Santino Dimarco is Chief Finance and Operations Consultant. Peter Kozushko is our North American representative, a contact point for church pastors who are interested in touching base with Undeceptions. Editing by Richard Humwe. Our voice actors today are Yannick Laurie and Dakota Love. Special thanks to our series sponsor, Zondervan, for making this Undeception possible. Undeceptions is the flagship podcast of undeceptions.com, letting the truth out. An Undeceptions podcast.